Hello all, welcome to session 10 of Unit 1 Basic Kinematics in Mechanics of Machine of 3rd semester Mechanical Engineering course. Let us summarize the things which we have learned in the previous session. So first thing is we have learned about the double slider crank chain. So what does a double slider crank chain means and how does the double slider crank chain works? These things are learned in the previous session. So what is double slider crank chain? So a double slider crank chain is an kinematic chain which has how many sliding pairs and how many turning pairs. It has two sliding pairs and two turning pairs. And also we have listed the inversions of double slider crank chain. In that we have discussed the elliptical trammel. So elliptical trammel is an inversion of double slider crank chain. What for it is used? Which is used for drawing the ellipses. So in the operation, this particular inversion, elliptical trammel inversion, is obtained by fixing the slotted plate. These are the things which we have learned or discussed in the previous session. So objective of this session, at the end of this, you will be able to understand Skocak mechanism and Oldham's coupling, which are the inversions of double slider crank chain. So the contents of this session which I am planned are Skocak mechanism, Oldham's coupling, and MCQs and the descriptive questions which may be asked at the end semester examinations. So here the first let us see the Skocak mechanism. So what is Skocak mechanism or how does it is obtained? So Skocak mechanism is an inversion which is obtained by fixing the link 1 or link 3. So by fixing the link 1, that is this is the link 1 or link 3. So here in this case we have fixed the link 1. So here you can see the link 1 forms the frame. So link 1 forms the frame and link 2 forms the crank and then link 3 forms the slider, that is A, and then link 4 which is the slotted bar. Link 4 is the slotted bar. So this particular mechanism, Skocak mechanism, is used to convert rotary motion to the reciprocating motion. So this picture you can clearly see the which are all link 1 and link 2, link 3, like that you can clearly make a difference here. So here link 1, that is the black color black color one which forms the frame, so which is fixed. This is the link 1 which is frame fixed, and then link 2 which is like a circular disc. This forms the crank, and then link 4 which is the slotted bar with the piston rod. This is the slotted bar with the piston rod, and then link 3, this is the link 3 which forms slider. This Skocak mechanism has two turning pairs and two sliding pairs. Which are those? So here the two turning pairs are link 1 and link 2. That is this link 1 and link 2 crank. Frame and then the crank forms the one turning pair, and then another turning pair is formed by the crank and then the slider, that is link 2 and link 3. So here there are two sliding pairs. So which are those? Link 4, that is slotted plate, slotted bar, link 4 and then the link 1 forms the one sliding pair, and then link 3, that is slider, and then the slotted bar forms the one more sliding pair. In total there are two sliding pairs and two turning pairs. So you can see the animation, how the Scotch-Jack mechanism works. So here, as you can see, the crank is rotating about a fixed point. This green one will forms the fixed point B. So the crank is rotating about this fixed point B. As this crank rotates, the this slotted or piston rod, slotted plate, slotted bar along with the piston rod is reciprocating. So as the crank is rotating about the fixed center B, the slotted bar, that is link 4, will be reciprocating. This is how the Scotch-Jack mechanism works. That is Scotch-Jack mechanism, which is used for the converting rotary motion of crank to the reciprocatory motion. So let us see the one more inversion, that is Oldham's coupling. So when this inversion, which is obtained by fixing the link 2. So Oldham's coupling is the another inversion of double slider crank chain, which is obtained by fixing the link 2. So when it is used, this particular Oldham's coupling is used when two parallel shafts are separated by a small distance. So when this two shafts, that is here, the one is the driving shaft, that is A, and then the another one is the driven shaft B. Both these are parallel shafts which are separated by a small distance. You can see here both the axis of shaft A and axis of shaft B are at a small distance. So these are separated by a small distance. On such cases, in these cases, the Oldham's coupling will be used. So as said, the Oldham's coupling or this inversion is obtained by fixing the link 2, that is supporting frame. So by fixing the link 2, this inversion can be obtained. So here in this Oldham's coupling, link 1 and link 3, link 1, that is flange, and then link 3, which is another flange, forms the turning pairs with link 2, that is supporting frame, and then link 4, that is intermediate piece. Link 4 is the intermediate piece which forms the two sliding pairs with link 1, that is one flange, and then the another flange. So link 4 intermediate piece which forms the two sliding pairs with flange, that is link 1, and then with the another flange, that is link 3. So I repeat, the Oldham's coupling inversion is obtained by fixing the link 2, that is supporting frame, and then here there will be two turning pairs and two sliding pairs. So which are those? So here the link 2, that is supporting frame, forms the two turning pairs. Link 2 forms the two turning pairs with link 1 and link 3, and then link 4, that is intermediate piece, forms the two sliding pairs with link 1, that is flange 1, and then the link 3, which is another flange. So in the construction, the flanges will have the diametrical slots. These flanges, that is link 1 and link 3, will have the diametrical slots cut at the inner face where the intermediate piece will slides or reciprocates. So here again the intermediate piece, so the link 4 is the intermediate piece which has diametrical projections. So link 4 is the intermediate piece which has diametrical projections, that is are tongs T1 and T2. So here you can see clearly this is the link 4 which has diametrical projections, that is this one is the T1 and this will form the T2, and then these are the flanges which have slots. You can see here clearly slots are cut in their inner faces here and here. These are the two flanges, one is link 1 and the other forms the link 3. So here link 4 and then the link 1 and link 3 are forged or for forming a tight fit or close fit. So link 4, this link 4, that is intermediate piece, fits closely with in the slots of diametrical slots of flange, that is link 1 and link 3. So during the working, this intermediate piece can slide in the slots of the flange. So in the operation, as the driving shaft A is rotated, so as the driving shaft A is rotated, the flange will C, that is flange link 1, which is rotated at the same angle. So this rotation of flange, that is link 1, causes the intermediate piece, that is link 4, to rotate at the same angle through the same angle as that of the flange. So further, as this shaft A corresponds to the or leads to the rotation of this rotation of flange, that is link 3. As this flange rotated, the driven shaft B will also be rotated. So during the working, so you can see here during the working, the initially as the driving shaft A is rotated, which rotates the flange with the same angle as the is rotated during the working. As the flange is rotated by the driving shaft, this intermediate piece is rotated at the same angle as that of the flange, and then which causes this intermediate piece causes the flange 3 to rotate at the same angle as that of the this driving shaft, which causes the driven shaft to rotate. So during the working, the velocities, the angular velocities of link 1, that is flange, and then link 3, that is another flange, and then intermediate piece will have the same angular velocity at every instant. So here during the rotation, as said, the intermediate piece, that is link 4, will slide in the slots of the flanges. During the working, this intermediate piece will slide in the slots of the link 1 and link 3. So you can see the animation here clearly. The animation of this forms the one shaft forms either this or this forms the driving shaft. One more shaft forms the driven shaft. This is the flange 1, and this will form the flange 2, and this is the intermediate piece. As this the driving shaft rotated, so the flange is rotating with the same angle as that of the driving shaft, which causes this one intermediate piece to rotate. As the intermediate piece rotates, this flange, that is link, another flange will also rotate it, which causes the driven shaft to rotate at the same angle as that of the driving shaft, or with the same speed as that of the driving shaft. This is how the Oldham's coupling is works. So in this session we have discussed about the working principle of the working of Scotch-Ack mechanism, which is an inversion of double-stator crank chain, and we have discussed about the Oldham's coupling. In the Scotch-Ack mechanism, which is used to convert rotary motion into the reciprocating motion, and then here the Oldham's coupling, which is used for transmitting the rotary motion from one shaft to the other shaft, which are separated by a small distance. Both these, Scotch-Ack mechanism and Oldham's coupling, are the inversions of double stator crank chain. So let us see the MCQs, or multiple choice questions, of this session. The first one is: Scotch-Ack mechanism is an inversion of single stator crank chain, double stator crank chain, 4-bar chain, 6-bar chain. So what is the answer? So Scotch-Ack mechanism is an inversion of, the answer is double slider crank chain. So the next question is, the inversion of Scotch-Jack mechanism is obtained by fixing link 1 or link 3, link 2 or link 4, link 2 or link 1, link 4 or link 3. So the answer is link 1 or link 3. That is, Scotch-Jack mechanism is obtained by fixing either link 1 or link 3. We discussed by fixing the link 1. The next question is, the inversions of double slider crank chain is Oldham's coupling, Gnome engine, pendulum pump, Whitworth quick return motion mechanism. So which is the answer? So the answer is Oldham's coupling. All this, that is Gnome engine, pendulum pump, Whitworth quick return motion mechanism, all these three are the inversions of single slider crank chain, whereas Oldham's coupling is the inversion of double slider crank chain. So next, the inversion Oldham's coupling is obtained by fixing link 1, link 2, link 3, link 4. So how the, by fixing which link Oldham's coupling is obtained? Which link? Let us see the answer. That is link 2. By fixing the link 2, that is supporting frame, Oldham's coupling is obtained. So the next question is, Oldham's coupling is an inversion of 4-bar chain, double slider crank chain, single slider crank chain, none of them. So what is the answer? So Oldham's coupling is the inversion of double slider crank chain. So the next question is, the Oldham's coupling is used to transmit motion when the two shafts are coaxial, the two shafts are perpendicular, the two shafts are parallel, which are separated by a small distance, the two shafts are inclined to each other. So what will be the answer? We have discussed, right? So it is the two shafts are separated by a small distance. So the next question is, Oldham's coupling has how many flanges? 4 flanges, 3 flanges, 1 flange, 2 flanges. So what is the answer? The answer is 2 flanges. In an Oldham's coupling, link 1 and 2, link 2 and 3 forms the turning pairs. So whether this statement is true or false. So this statement is a true statement, as link 1 and 2 and link 2 and 3 forms the turning pairs. In Scotch-Jack mechanism, there will be 3 turning pairs. True or false? How many pairs does a Scotch-Jack mechanism 3? How many number of turning pairs Scotch-Jack mechanism has? Whether 3 or 4? How many? It is, this statement is false. It has 2. So the answer is false. So Scotch-Jack mechanism has only 2 turning pairs, right? So the next and last question is, Scotch-Jack mechanism has 4 turning pairs, 3 turning pairs and a sliding pair, 3 sliding pairs and a turning pair, 2 turning pairs and 2 sliding pairs. So how many? That is, the answer is 2 sliding pairs and 2 turning pairs. These are the kind of descriptive questions you can expect in the end semester examinations. So that is, explain with a neat sketch an elliptical trammel, explain with a neat sketch Scotch-Jack mechanism, explain with a neat sketch an Oldham's coupling. So explain with a neat sketch which finds the application when the two shafts have small misalignment, that is when the two shafts are separated by a small distance. So in this case we need to write the Oldham's coupling. some of the suggested activities are, so you should at the after this session you should maybe you visit any of the machine shop or workshop, observe the lathe, uh, list the mechanisms, and which are all the different kind of mechanisms you find in a lathe, and observe them closely, how they are operating or how they are working. And then try to visit any machine shop or a workshop, maybe in your college or outside any machine shop or the workshop. So observe various mechanisms which will incorporate various mechanisms. You will get an idea how those mechanisms will be operating. So try to visit any machine shop or the workshop, maybe in the institute or in the outside. So the other suggested activities: observe the mechanisms which you maybe you will daily we will see the in our day-to-day life we may see so many kinds of mechanisms. So it may be if it is in a four-wheeler, we will observe the coupling rod, and then if it is in two-wheeler also we will observe the mechanisms. So like you will observe a lot of mechanisms. Try to try to observe them closely, which are the different kinds of mechanisms are used surrounding you. So this is the book which is a reference book, that is Theory of Machines by R.S. Kurmi and J.K. Gupta. Thank you for patience listening.